Let's start with the weird stuff science quietly sweeps under the rug and slowly work our way towards the most bone-chilling mysteries that keep researchers awake at night. Number 8. The bloop. In 1997, underwater microphones operated by the National Oceanic and Atmospheric Administration picked up a sound, an ultra-low frequency noise so loud it was detected by sensors more than 3,000 miles apart. They called it the bloop. When scientists sped up the recording to make it audible to human ears, it sounded organic, like something alive, and it was massive. The ocean is full of sounds, whale songs, ship engines, underwater earthquakes. Scientists know what all of those sound like. The bloop didn't match any of them. It was far too loud to be any known marine animal. Blue whales are the loudest creatures on Earth, and the bloop made them sound like a whisper. Whatever produced that sound would have to be significantly larger than any creature we've ever discovered. The official explanation came years later. NOAA said it was probably an ice quake, a massive chunk of ice breaking off an Antarctic glacier. The sound profile matches. The location makes sense. Case closed, except here's what bothers people. Ice quakes happen all the time in Antarctica. This one was never heard again. Nothing remotely similar has been recorded since, even though the microphones are still there, still listening. So either we got incredibly unlucky and caught a one-time freak ice event, or something else made that sound. Something we've never seen before or since. Number 7. The WOW signal. August 15, 1977. The Big Ear radio telescope at Ohio State University was doing what it always did, scanning the sky for interesting radio signals. At 10:30 p.m., it detected something that made no sense. A signal 72 seconds long, coming from the direction of the constellation Sagittarius. The signal was so strong, so unusual, that when astronomer Jerry Amon reviewed the data printout, he circled it and wrote one word in red pen. Wow, here's why it matters. The signal was exactly the frequency scientists expect an intelligent civilization to use for interstellar communication. It was narrow band, meaning it wasn't natural. Natural radio sources are messy and spread across many frequencies. This was precise, deliberate, and it came from a part of the sky with no known stars close enough to have sent it. Astronomers have pointed telescopes at that same spot hundreds of times since 1977. Nothing. The signal never repeated. Every natural explanation has been tested and failed. It wasn't a satellite. It wasn't Earth-based interference. It wasn't a passing comet, though some tried to make that work. One of the most credible signals we've ever detected that could indicate intelligent life. And it showed up once, said hello, and vanished forever. We're left with two options. Either we witnessed a one-time transmission from something unimaginably far away, or there's a natural phenomenon we don't understand that can perfectly mimic an artificial signal. Take your pick. Number 6, the placebo effect. This one's happening in hospitals right now. A patient gets a sugar pill. They're told it's medicine, and they get better. Not just a little better, sometimes dramatically better. Pain disappears, symptoms fade. In some cases, the placebo works almost as well as the actual drug. Science has documented this thousands of times, and we have no idea how it's possible. Here's the thing, the placebo effect isn't just about positive thinking, it's measurable. Brain scans show real changes. Patients in placebo groups produce actual endorphins, actual changes in neural activity. Their bodies respond as if they received treatment, even though they got nothing. And it gets weirder. Even when patients know they're taking a placebo, it sometimes still works. Researchers have literally said, this is a sugar pill, it has no active ingredients, and handed it to patients. And those patients improved anyway. We've got theories. Maybe it's about expectation triggering biological processes. Maybe it's the ritual of treatment that matters. Maybe there's something about the patient-doctor relationship. But none of that explains the mechanism. How does believing something translate into actual physical healing? How does your brain decide to release pain-relieving chemicals just because you think you took medicine? The placebo effect is so reliable that every drug trial has to account for it, but we can't tell you why it works. We just know it does. Number 5, dark matter and dark energy. Ready for this? Everything we can see, measure, and interact with, every star, planet, atom, and particle we've ever discovered, makes up about 5% of the universe. 5%. The other 95% is stuff we can't see, can't touch, and barely understand. We just know it's there because without it, nothing makes sense. Dark matter first. Galaxies spin way too fast. Based on the visible matter we can see, they should fly apart. The stars on the outer edges are moving so quickly that the galaxy's gravity shouldn't be able to hold them. But they don't fly apart. Something invisible is adding mass, adding gravity, holding everything together. We call it dark matter. We know roughly how much there is. We know where it is, we just don't know what it is. It doesn't interact with light. It doesn't interact with regular matter except through gravity. Every attempt to directly detect a dark matter particle has failed. Then there's dark energy. This one's worse. The universe is expanding. That's fine, we've known that for decades, but it's expanding faster and faster. Something is pushing space itself apart, overcoming gravity, accelerating everything away from everything else. We have no idea what's causing it. We call it dark energy, and it makes up about 70% of everything, the dominant force in the universe, and we can't explain it. So let's recap. We don't know what 95% of the universe is made of. We've built billion-dollar detectors, launched satellites, and crunched decades of data. And the answer is still, we see the effects, but we have no clue what's actually causing them. That's not a mystery. That's a confession. Number 4, the Fermi paradox. There are billions of galaxies, hundreds of billions of stars in each galaxy, countless planets. Many of those planets are in the habitable zone. Some are billions of years older than Earth. If life is even remotely common, the universe should be absolutely packed with civilizations. Some of them should be so advanced they've had millions of years to spread across the galaxy. We should see signs everywhere, megastructures, radio signals, probes, something. We see nothing. This is the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked, "Where is everybody?" during a casual lunch conversation. It's not just a fun question, it's a legitimate scientific problem. The math says life should be everywhere. Our observations say we're alone. Both can't be true. The proposed solutions are all disturbing in different ways. Maybe intelligent life always destroys itself before it gets far. Maybe there's a great filter we haven't passed yet, some cosmic trial that wipes out civilizations. Maybe aliens are here and we're too primitive to notice. Maybe they're avoiding us on purpose. Or maybe we're genuinely the first, the only ones who made it this far. Every answer is unsettling. Go ahead, pick one. If you chose the great filter and we haven't passed it yet, well, that means something ahead of us wipes out every species that reaches our level. If you chose we're being avoided, congratulations. We're either a zoo exhibit or a quarantine zone. All right, let's try another one. If advanced civilizations always destroy themselves, we've got a timer we can't see. If we're actually alone, the universe is far stranger and emptier than anything we imagined. There's no good answer here, just different flavors of cosmic horror. Number 3, consciousness. You're reading this right now, you're aware that you're reading it, you have thoughts about it. You experience the sensation of understanding these words. That awareness, that subjective experience of being you, is consciousness. And science cannot tell you how it happens. We know the brain is involved. Obviously, damage certain parts and consciousness changes. We can even identify brain regions associated with different aspects of awareness. But here's the problem. Neurons are just cells. They fire electrochemical signals. That's it. How do billions of tiny electrical impulses become the experience of tasting chocolate, or feeling sad, or recognizing your own face in a mirror? How does meat become a mind? This is called the hard problem of consciousness, and it's remained unsolved for centuries. We've made incredible progress in neuroscience. We can map brain activity, identify patterns, predict behavior. But none of that explains subjective experience. Why does it feel like something to be you? Why is there an inner world at all? Why aren't we just sophisticated biological robots processing information without any awareness of doing it? Some scientists think consciousness emerges from complexity. Get enough neurons firing in the right patterns, and awareness somehow appears. Others think there's something fundamental we're missing about the nature of reality itself. And some think the question might be unanswerable with our current methods. We can study the brain forever, but we might never bridge the gap between neural activity and subjective experience. Here's what makes it disturbing. You are conscious right now. You know you are. It's the most immediate, undeniable fact of your existence, and science has no idea how it's possible. Number 2, quantum entanglement. Einstein called it spooky action at a distance, and he hated it. Here's why. Take two particles that have interacted, separate them, put them on opposite sides of the galaxy if you want. Now measure 1. The instant you do, the other particle changes, instantly, regardless of distance. No signal passes between them, no time delay. They're connected in a way that seems to violate everything we know about how information and causality work. This isn't theoretical. Scientists do this in labs constantly. It's proven. Entangled particles really do affect each other instantaneously across any distance, and it breaks the rules. According to relativity, nothing can travel faster than light. Information, energy, nothing. But quantum entanglement doesn't seem to care. The particles coordinate their behavior with zero delay. The math works. Quantum mechanics predicts this, and the predictions are accurate to an absurd number of decimal places. But the math doesn't explain what's actually happening. How do particles that are light years apart know what the other is doing? How does the universe maintain this connection? Some interpretations say the particles aren't really separate. They're aspects of a single quantum system that exists everywhere at once. Some say there are hidden variables we haven't discovered. Some say the question itself is meaningless and we should just accept what the math tells us. What disturbs physicists isn't just that it happens, it's that our most successful theory in all of science, a theory that's been tested more rigorously than anything in history, fundamentally requires something that seems impossible. We can use entanglement. We're building quantum computers with it. We're developing unbreakable encryption. But ask a physicist to explain how it actually works, and you'll watch them struggle. The universe is doing something we can describe but can't understand, and that's terrifying. Number 1, the Great Attractor. Our galaxy is moving. Not just drifting, moving fast. Our entire galaxy, all 400 billion stars, is being pulled towards something at over 1 million miles per hour, along with everything else in our local group, along with thousands of other galaxies. Something massive is out there, something unimaginably large, and it's dragging a huge chunk of the visible universe toward it. We can't see it. It's hidden behind the zone of avoidance, a region of space blocked by the dense disk of our own Milky Way. But we can measure its effects. By tracking how galaxies move, scientists calculated where this thing has to be and how massive it has to be to create the pull we're experiencing. The numbers are staggering. Whatever the Great Attractor is, it's pulling hundreds of thousands of galaxies, and we're headed straight for it. For years, we thought it might be an enormous concentration of mass, a supercluster of galaxies. Then telescopes improved. We started seeing through the dust. What we found was a structure called the Norma Cluster. Big, sure, but not nearly big enough to explain what we're observing. The pull is too strong. There's not enough visible matter. So either there's something else out there we still haven't found, or the distribution of dark matter is far stranger than we thought. Then it got worse. Astronomers discovered an even larger structure beyond the Great Attractor. They call it the Shapley Supercluster, and it might be contributing to our motion too. Or maybe the Great Attractor itself is being pulled by something even bigger. We're moving towards something, through something, and we don't know if we'll ever reach it or what happens if we do. We're passengers on a cosmic ride we didn't choose and can't stop, headed toward a destination we can't see. Hands down, that's the most disturbing part. The thing pulling our galaxy isn't some distant curiosity. We're in it, right now, falling towards something massive at speeds that make hurricanes look still. And there's nothing we can do except watch and measure and wonder what's waiting at the end. So here's what we've covered. Strange sounds only some people hear. Glowing spheres that defy physics. Ocean noises too big to explain. A signal from space that might have been hello. Sugar pills that heal real diseases. 95% of the universe we can't identify. A galaxy that should be full of life but appears empty. Consciousness that shouldn't exist but does. Particles that communicate across impossible distances. And a cosmic monster dragging us toward an unknown fate. Science is supposed to give us answers. Most of the time it does. But these mysteries, these are the cracks in our understanding, the places where our best theories fall apart and we're left staring at evidence we can't explain. Some of them might be solved tomorrow, some might take centuries, and some might be fundamentally beyond our ability to understand. That's the disturbing part, not that we don't know, but that we might never know. If you want more mysteries that'll keep you up at night, there's a video on phenomena science refuses to study that you definitely need to see.